All right, so we're the Screaming Sirens, and we did ours on the Honda and Toyota car model detector. And my name's Jack.
My name is Ira.
I am Samir.
My name is Aditya.
My name's Matthew.
Aiden.
So, our project and idea outline. We wanted to address a couple of problems with our project using computer vision. And so, we thought that the best projects that we could address with cars, with identifying cars, would be to finding the average car price at a dealership or identifying a stolen car that's been parked somewhere. And the basic outline of our computer vision system is we wanted the user to be able to upload a car image on our website, and then our trained AI would take in that image and then output a classification of the car brand and model and how confident it was that that was the correct model. At the moment, it's confined to Honda and Toyota cars, but we are looking forward to expanding it. And then lastly, it would return the output, and then the format.
The tech stack consists of the website and the AI. It's essentially the software that we used in order to essentially build the AI and also build the website. The website's front end has HTML and CSS, where we used Bootstrap as a template to start putting in all of the elements together. The back end of the website is Flask, which we put in braces as blank spaces inside the website, and then Flask fills them in. So we can have custom images and custom descriptions and labels for the user putting in images into the website. For the AI, we first use SERP API to scrape the data off of Google Images to automate collecting all of the car images for the data collection. We then use RoboFlow to attach labels to each of those images to train the AI properly. It also allowed us to augment the data so that we can choose to flip it left and right, and we can also choose to add noise to it. Finally, we have Yellow V5, which is the AI itself. We use their models to essentially find a pattern between the labels and the images, which will train the AI. Once we have the models, the weights essentially, we could then just have Flask and the website display that. So this is how you would be able to use the website to have the AI recognize a car.
All right, so how we collected data. So the first thing we realized is that collecting data for every single car brand and model out there is just way too much. I mean, especially in only 3 weeks. So to start off with, we decided to only do Honda cars, and every person in our group chose a specific model, and we used SERP APIs, Matthew mentioned, to collect around 100 images each, all automated. Then we marked these up in RoboFlow, and the first time we ended up training our model with around 500 images. And the model was working pretty good at that point, and so we decided to go back, and since we had the time, add in the Toyota car brands. And once we did that, again using SERP API, we ended up training our model with 1,500 images.
So after we collected our data, we trained our model using YOLO V5. We underwent 3 rounds of training, and as Samir said, the first round was exclusively Honda models, which included the Pilot, Clarity, Ridgeline, Odyssey, Accord, and Civic. We also utilized a data augmentation feature of flipping. In the second round, we added some Toyota models, which included the 4Runner, Camry, Corolla, Highlander, Prius, and Supra, and utilized an additional data augmentation feature of noise. In our third and final round of training, we retrained the model without noise augmentation, since it was previously causing errors.
All right, so for our data set, we also introduced some data augmentation for the first and second run. So we wanted our program to be able to detect Hondas and Toyotas in scenarios that aren't just perfect views, like just normal images. We wanted it to be capable to detect cars in bad quality photos or just bad weather, like snow or rain. So one method we use to try and replicate that so the AI can recognize those scenarios is image noise. Image noise is basically described in the image above, where we add random pixels into the image to lower the quality and make it harder to recognize the car. It trains the AI to take into account varying qualities of the images, but this was removed because it caused issues with the quality of our model's detection. Another method we used was flipping the images. As we all know, there's many different ways you can take a photo of a car. It's not going to be in one perspective. So flipping the images allowed us to get like different angles on the car. So we could have the AI recognize all sides of the car and figure out what car it is specifically. Both of these methods assured that our AI could have a solid detection system that works in bad and good conditions.
So this would be our first round of data after we originally trained our model. We can only see Honda models, of course, at this point. But as you can see in our confusion matrix, it's fairly accurate detecting the Honda models. The only thing that it was slightly confused on is with the Honda Accords blending into the background. And we can move on to our second round of data now. And as you can see with the second round of data, we added the noise data augmentation, and you can see it kind of screwed up our model a little bit. It was double selecting cars like you see on the Honda Civic in the bottom left, as well as the yellow Honda Civic on the top. It missed half of it. Pay special attention to that yellow Honda Civic. We can see in our next one, it cleans up a lot. And as you can see in the top left, our Honda Civic was much nicer after we removed that noise augmentation, and our confusion matrix still looks pretty good.
All right, and then for our final data, as you can see, we were identifying both Honda and Toyota cars. And you can also see we put in a Tesla car and it didn't identify the car. So we trained the data set to not identify cars that weren't Honda or Toyotas. And then we also had a blank road. And this just shows that we were allowing the AI to see that if there weren't any cars, it didn't have to highlight anything. And then we're in our website. All right, so this is our website. So here's our title, and then our motive. This is where our motive is. And then the resources used, some examples. And then here's our team. So Adita, Ira, me, Aiden, Matthew, Samir, and Alex was our instructor. And here's our timeline. So within the first week, we did the brainstorming and learning Python. The second week, we identified the images and trained the data set. And the third week, we worked on our website. So to work with the car detector, if you upload an image here, so the first image, it doesn't have anything. So just 90%. As you can see, it didn't identify a car. And then if we try this one, this is a Honda Accord, so I correctly identified this one. And then this is a Toyota Prius, it's 95% confidence. And then we also have a car, this is a Jeep, but it didn't identify it because it didn't recognize the type of car. And this is our website.